Hello students, I hope you all are safe and healthy. Under subject science, physics, in the previous class we started with a new chapter that is force and pressure. And in this we learned about the introduction of force with its definition, and you also learned that there are two objects which is required for the force to exist. And in today's class, let us explore more about forces. Students, imagine there is a huge box or a block. Now, you alone are trying to move it from one place to another. Will you be able to move? Will you be able to move? No, it's not possible because it's very heavy. Now, you call your another friend and you both together try to push this particular object. Now what happens? It will move with a easier way. It will be a little more easy for you to move. But in this case, we don't know who is applying more force than the other. Both might be applying, but we don't know who is having more strength, right? So here it becomes that there are unbalanced forces acting upon an object in the same direction. So both are standing in one side and they are applying force in the same direction. So this is the direction of the force. So what happens in this case is that the forces gets added up. For example, if you take this person's force as F1 and the other person's force as F2, now when they are acting on the object, when they are applying force on an object in the same direction, here it's given in the same direction, the net force is nothing but the sum of the two forces. So the unbalanced force acting in the same direction is combined by the addition. So the net force will be equal to F1 plus F2. So this is one case. Now students, imagine you and your friend are applying force on the object in opposite direction. See, here is this person over here and here another one. Now what will happen? And again here comes the picture of unbalanced forces. So if this A is having more force, then the object will move in this direction. If the B is having more force, then the object will move in this direction. Correct? So what happens in this case is that again the unbalanced forces come into picture, and then in this case, since the force is being applied in the opposite direction, the forces gets subtracted. But it depends upon how much of force is applied in whichever direction it is. If this is having more force, object will move in this direction, this particular direction. So you can say that if F1 and F2 are the two forces, if F1 and F2 are the two forces, F1 will be greater to F2 means the net force will be equal to F1 minus F2. Now if the F2 force is greater than the F1, the force 2 is greater than the F1, then the net force will be equal to F2 minus F1. So the effect of the object depends on the net force acting on it. So the forces will get subtracted if the forces are acting in the opposite direction. So this is another case. Now look at this particular image. Here is a rope and there are two persons who are trying to pull it in the opposite direction. But in this case, students, both are applying the same force. Now what could be the net force in this one? What could be the net force? Here the net force will be 0. That's because both are applying the same amount of force on the object, but in opposite direction. Now what happens to the object is that the object will not move. The object will be at its state of rest itself. There won't be any changes when the forces are equal and when the forces are in the opposite direction. So when the forces are equal and in the opposite direction, there won't be any net force. So the net force will be 0. Here you can see that if F1 is equal to F2, the net force will be equal to the F1 and F2 forces will be cancelled and the net force will become 0. But there are chances that there might be the change in size and shape of the object when there is equal force applied on an object. So these are the 3 cases of the force. Now students, let us see the direction of force with its magnitude. So what is magnitude? Magnitude of force is nothing but how much of force is applied on an object. Now if you apply more force, the object will move faster. If you apply less force, the object will move slower. So that is nothing but the magnitude. Now direction means in whichever direction you are applying the force, the object will move based on that particular direction of the force. So that is nothing but the force is having direction as well as magnitude. Now students, see here is the example. When there are 2 students applying force on an object in the same direction. Now what happens? The movement will be faster. The forces will be added up. So the F will be equal to F1 plus F2. Now let us see another situation where you have a ball. Now when you try to push the ball on the table with slower speed and you try to keep the hand on the opposite side, what will happen to the ball? It will come and touch your palm and it will stop after moving. Now if you are applying the ball with greater speed, what will happen? Again over here, it will come and hit your palm and again come back. It will roll back with different speed. And coming to this one. Now here in this, the object is already in motion in this particular direction. Now if you try to hit this particular ball with the ruler, what will happen? Will it stop here? No, it won't stop. It will try to come back in another direction. So here it shows that even when the object is in motion, if you apply the force in the other direction, definitely the object will change its state of motion. It's moving in this direction, again it's coming back in the other direction. So whenever the object is in rest, when you apply force, it will move. Also, even when the object is in motion, you can change the state of the object. Or if the object is in motion, you can also stop the object. For example, if somebody is throwing the ball, you will try to catch it. That means you are stopping the movement of the object. Clear? So here it shows that a force can change the state of motion. Now let us see what is state of motion. So the state of motion of an object is described by its speed and the direction of motion. Less speed or more speed, also with its direction of motion. And the state of rest is nothing but the speed will be 0. And any object